Hello children, how are you doing? In this lecture, I will briefly discuss about all the different theorems that we have in angle properties, and then we will quickly discuss a sum. So let's look it up. Now, when we talk about a circle, then obviously I'm sure you people can also define a circle. What is a circle? Just tell me. Yes, I'm giving you 3 seconds time. You should be able to at least define a circle before studying circles, isn't it? Can't? Well, I'll tell you. If we have a fixed point and there is another movable point, and the movable point moves in such a way so that its distance from the fixed point is always fixed, then the path traced out by the movable point, say some p, is said to be a circle. I'll quickly repeat. If there be a movable point which is moving in such a way so that its distance from another fixed point is always fixed, then the path which is traced out by this movable point will be a circle. Okay, now let's come to certain theorems. So if, say, we now talk about, say, this point to be the center of the circle, right? And let's say we have a circle like this, then one of the first theorems which are there in angle properties is this, that if, say, you talk about an arc of a circle, right, on which you talk about an angle, then that is equal to half of the angle formed on the same arc of the circle at the center. So here we have this to be the center of the circle, right? I'm encircling it so that you can understand and see this better, because this is just a small dot, right? Now, if you talk about this segment of the circle or this arc of the circle, we can say name it to be, say, some AB. Now we are interested to find out the angle on this arc of the circle at the circumference, let's say at a point C, right? And let's say if we talk about the center of the circle, let's say that point be some P, right? I'm writing it outside because we'll be doing some things here. Okay, now if you talk about another angle, that is the angle which is formed at the center of the circle, right, using the same arc of the circle, that is AB, then it can be represented this way. That is like this, right? So now here we have two angles. One angle is this, right? And let's say if it's theta, then this angle is going to be 2 theta, right? So I'll write the theorem for you people. And please write along with me so that you can memorize. Angle at the center of a circle is double the angle formed at the circumference on the same arc, right? So this, children, is the first theorem that we have in circles, right? Now in angle properties of circles, this theorem also requires to be learnt with its proof. So I'll just quickly tell you people about its proof. So what you do is you draw a straight line from the point on the vertex where both the chords have intersected, and let's say if we talk about this to be passing through the center of the circle and be extended a little forwards, right? So as such, here I'm sure you're able to see that we have one triangle which is this, right? As we've named this point to be P, so PCA is one of the triangles, and another triangle is PCB, right? Now if we talk about both of these triangles, there is a speciality, and that is this: we find that both of these triangles are isosceles triangles because PA is equal to PC, and similarly you have PB to be equal to PC, right? So thus both of these are isosceles triangles. Now if we consider this angle to be, say, some x, obviously this angle also is going to become equal to x. And similarly, if we consider this angle to be, say, some y, then obviously this angle also is going to be equal to y, right? Now I'm sure you people remember a theorem in triangles, that is, the exterior angle of a triangle is equal to sum of the interior opposite angles. That means that this is the exterior angle, right? And if, say, we are interested in this exterior angle, then this exterior angle is going to be equal to the sum of the interior angles to opposite angles. So to this interior angle, this is an opposite angle. To this interior angle, this is another opposite angle. And if you add them up, that should give you the exterior angle, right? So here as such, the exterior angle will become equal to 2x. And similarly, in the other triangle also, we have here this triangle where if you talk about this angle, this is the exterior angle, and it should be equal to the sum of the two angles which are opposite to this interior angle, that is these two angles. And as you know that the sum of both of these angles is going to be equal to 2y, as such, in a similar way you can say that this is 2y. And thus if you talk about this angle which is getting formed at the center on the same arc of the circle, it will become equal to 2 times of x plus y, right? Sometimes you require the proof of the theorem, right? And that is very much handy either in proving or probably finding out certain angles. So I'll just quickly repeat this. Now you have angle formed by two chords on an arc of a circle. Now on the same arc of the circle, if you talk about an angle, it is also formed at the center of the circle. Angle at the center of the circle on the same arc is double the angle formed on the circumference on the same arc of the circle. Now to prove it, what we do is we draw a straight line from the point of intersection of both the chords to the center of the circle and extend it forwards. Now we get two triangles. One is this, that is PAC, and the other is P, right, CB. Now both of these triangles are isosceles triangles, as PA and PC are radii. Similarly, PC and PB are also radii, and as such the base angles are going to be equal. So if this is x, this will also be x, and if this is y, this will also be y. Now next what we do is we talk about the exterior angle of these triangles. That will be equal to sum of the interior opposite angles, that is 2x, right? And similarly, if we talk about this angle is going to be 2y, as the exterior angle of this triangle is equal to sum of interior opposite angles, right? I'm sure you people are able to understand this, that this is the exterior angle of this triangle because this side has been produced forwards, and if you find out its angle with another side, this is known as the exterior angle, right? So as such, here we now have the sum of both of these exterior angles to have come to where we can take 2 to be common outside. As such, 2 times of x plus y is what we have here. And if you talk about this complete angle, is it not x plus y? And thus we've seen here that the angle at the circumference is half the angle at the center on the same arc of the circle, or we can say that the angle at the center is double the angle at the circumference on the same arc of the circle. Now children, let's proceed further. Now there's another theorem which is there, which can be done off with in this figure itself, so I'll make it here itself. So let's say now that we talk about, say, an arc of a circle that is the same, that is AB, and on that now let us quickly try and make such that there are two chords which intersect to be having the same angle which was on the arc AB, right? So our theorem is that angles which are on the same arc of the circle at the circumference are equal in value. So if you talk about this angle to be x plus y, then this angle also is to be x plus y. Obviously this can be proved very simply, because you will say that angle at the center will be double the angle at the circumference. So if this angle is, say, some x plus y, then at the center the angle subtended is 2 times of x plus y, and similarly, as this angle is also getting formed on the same segment of the circle, thus, if you talk about this angle, if it is 2 times of x plus y, the angle at the circumference will be half its value, that is just x plus y. Thus, now you can say that angles on the same segment of the circle or the same arc at the circumference are always equal, right? So this is the next theorem that we require to write. So along with me, do write, and that will help you in memorizing this, because memorizing is something which is very important, and it should be done in such a way so that it is not understood that you are learning it, and it should get learned, right? So write along with me in your registers. Angle on an arc of a circle at any point of the circumference are equal, right? So if you have different points which are there on the circumference of the circle, and if you draw two chords so that they take up that specific arc that you're talking about, then the angles which will be formed by each of these two chords will always be equal, right? Now, another way to say it is that angle which is formed on the same arc, right, at any point in the circumference will be equal in magnitude. Okay, now children, after this we have the next theorem, and which is an important one. That is this, that if suppose there is a circle and we have, say, 4 points on the circumference of the circle. So let's say this is a circle, and now let's say we have 4 points on it, such that now that we have 4 points on the circumference of the circle, we can now join them to make a quadrilateral, right? And such sort of 4 points which can be joined to form a quadrilateral such that they are on the circumference of the circle are known as concyclic points, right? So here, as such, now we have such a sort of a quadrilateral which is getting formed that all of its vertices are on the circumference of the circle. And you also have to remember that if you talk about these 4 points, these 4 points are said to be concyclic, right? CONCYCLIC, right? And thus a cyclic quadrilateral has been formed. So if we name it to be, say, some A, B, C, D, right, then you can say that a cyclic quadrilateral is such a quadrilateral which has all of its 4 vertices on the circumference of the circle, and all of these 4 points are said to be concyclic if they are on the circumference of the circle. Now children, whenever we have such a cyclic quadrilateral, there is a special property. That is, if you talk about one angle of the cyclic quadrilateral, and if you leave the other, then you will get the opposite angle of the cyclic quadrilateral. Now, if, say, one angle is theta, then the other angle will come to be 180 minus theta, right? So the theorem goes, angles which are opposite to each other in a cyclic quadrilateral are supplementary, right? So similarly, thus, you can say that if you talk about this angle to be, say, some alpha, then obviously this angle is going to be such that the sum of both of these is supplementary. As such, this will be 180 minus theta. I'm sure you people know that if two angles sum up to 180 degree, then they are said to be supplementary. So now, along with me, you will be writing this, and the proof of this is very simple. As such, I'm not discussing it. Okay, so along with me now, in your copies, write what this theorem is. The sum of the opposite angles of a cyclic quadrilateral is supplementary, right? So this is the next theorem, and in this I will make now the things which are required for the next theorem. Now let us say we now talk about extending one of the sides of the cyclic quadrilateral, say something like this. And obviously here we will get the exterior angle of the cyclic quadrilateral. And if say we talk about this exterior angle of the cyclic quadrilateral to be, say, some angle which is theta, right, then it will be equal to the interior opposite angle. That means if you talk about this angle, again let's take some special ink. So if we talk about this angle, children, then this angle will also be theta. So as I have written theta here earlier, so let's talk about some other angle. Let's say we talk about beta. So this angle is going to become equal to beta. So here too I will make this angle to be beta and rub this off, right? So what did I say just now? I said this, that exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So exterior angle of any quadrilateral or any polygon can be got if you extend one of the sides of that polygon, and then if you find out its angle with another side which is adjacent to it, then that becomes the exterior angle. Now this exterior angle of the cyclic quadrilateral is going to be equal to this this angle's interior angle, that is this, and when we go to the opposite angle, then one angle leaving the other is going to become the opposite angle, right? And both of these angles are going to be equal. Now that's pretty simple here, because if you talk about this angle to be beta, then this is going to become equal to 180 minus beta. And as you know that the opposite angles of a cyclic quadrilateral are supplementary, thus this angle will come to be beta, right? For that matter, let me quickly tell you people about the proof of this theorem also. Otherwise you people probably will be reckoning, why is it that the proof of this theorem was left? That is, some of the opposite angles of a cyclic quadrilateral are supplementary. So for that matter, now let us consider that we have the center of the circle to be, say, somewhere here, right? Especially I'm trying to mark it here so that there is something special which can be done, which in times to come I will tell you. Now if say we are to draw two lines such that they reach B and C, so this is one of the lines, and the second line is going to be this, that it is going to now reach A. Now why did I take the center of the circle a further little inside, not where it should be, so that if I would have taken it here, then by joining it to the vertices it would have been a straight line. I want you to see that when we are joining the center of the circle to the endpoints of a chord, right, it is not coming out to be a straight line, and thus you'll be able to understand much more. Now children, if we talk about, say, this angle, right, then let us consider that this angle be, say, some, again, another new angle which is delta. Okay, all of these alpha, beta, gamma, delta, they're all Greek alphabets. So if this angle is delta, right, you get to see that this is getting formed on AB segment of the circle, right? And now thus, if you talk about another angle which is getting formed on AB segment of the circle, right, but reflex is this angle. So if you talk about the other angle which is just such that the sum of both of these angles be 360, that is angle about a point, this angle is going to become equal to 360 minus delta, right? Now if you talk about a segment of the circle which is for this angle, children, then here we can see it as, now this angle being delta, right, the angle which is formed on the same segment of the circle at the circumference, right, is going to be half of it, right? This is what the theorem is. So if, say, we now draw two lines such that we can earmark two chords, right, which are getting formed on the same segment AB of the circle, then if, say, we just draw a straight line like this, right, don't we get two chords here, right? One is the chord AD and the second chord to be DB, right, which has an angle on the same segment of the circle, but now at the circumference. So obviously this angle is going to become equal to how much? It is going to become equal to delta divided by 2. That means half. Now children, using this, we will now be doing another thing which will help you understand this. Now quickly, I'm going to remove all of this theorem that I explained to you just now, and we will come into the proving of this theorem that opposite angles of a cyclic quadrilateral are supplementary, right? And for that, then what we do is, let us now do just one thing, that is, let's now remove this angle, and in place of just taking one chord, we will rather take a segment of the circle. For that matter, let us now consider that we have the segment of the circle which is to be taken, say, to be the one which already has theta. That means we will take it to be drawn such that one of the straight lines drawn is here from the center of the circle to A, and the other, say, be taken up to C, right? Something like this. So here as such, now you get to see that the segment of the circle that we are talking about, right, is actually AC, right? And the angle which is at the circumference of the circle, that is theta. Now here, if we talk about, not with respect to delta, but now with respect to theta, if we talk about the angle which is getting formed at the center, right, then that obviously is going to be double the angle which is getting formed at the circumference, right? And thus this angle is going to become equal to how much? This angle will now become equal to 2 theta. Yes or no? Right? So we had this theorem which I showed you just now, right? So if you talk about the angle which is getting formed at the circumference of the circle, if it's theta, then the angle formed at the center of the circle on the same segment of the circle, which is ADC, is going to be 2 theta, right? Now let's talk about the rest of the angle. So if you talk about the rest of the angle, as we know that the angle about the point is 360, so the rest of the angle is going to become equal to 360 minus 2 theta, right? Now, if you talk about this angle, which is 360 minus 2 theta, right, this is not getting formed on ADC, but it is actually getting formed on the rest of the circle because it is on the other side, right? So 360 minus 2 theta is actually getting formed on ABC segment of the circle, and now on ABC segment of the circle, if you require an angle at the circumference, obviously you require to join the endpoints of this arc with chords. And now when it is formed, won't it become half of the angle which is at the center? So it is going to become equal to 360 minus 2 theta, which was the angle at the center, divided by 2. Right, so obviously this is going to become equal to 360, which is going to be divided by 2, and 2 theta, which is going to be divided by 2. As such, it will become equal to 180 minus 2 theta, 180 minus theta, right, which is what we have here at the vertex ADC, right? So this stands proved. So I'll just quickly discuss this once more. What I said was that if, say, we have the center of the circle to be here, right, and let's now join it with two vertices of the cyclic quadrilateral. One is A and the other be C. So now we are talking about an angle theta which is getting formed on ADC segment of the circle. So obviously on the segment of the circle ADC, at the center, an angle 2 theta will be formed, right? And since angle about a point is 360 minus theta, so obviously here, angle about a point is 360, so obviously here angle about the point will be this 2 theta, and except that rest, right, which is to be subtracted from 360. That means 360 minus 2 theta will be the rest. And as this angle was on this segment of the circle, right, so this angle will be on the other segment of the circle, that is ABC, right? So this angle is going to be 360 minus 2 theta. Now remember, this is an angle which is getting formed at the center of the circle. So the same angle which is now going to be formed on the segment ABC, not at the center but at the circumference, will be this angle which is getting formed on ABC. And that should be half this angle, that is 360 minus 2 theta divided by 2, right? And since we know that if we have some a plus b, if it is divided by c, then that can be written as a upon c plus b upon c. That is, we can break up the fraction like this. So here we have broken up the fraction. We've written this to be 360 upon 2 minus 2 theta upon 2. So this then becomes equal to 180 and this becomes equal to theta. So as such here, we will now have the angle which is this on the segment of the circle ABC to be half this angle, and which comes out to be 180 minus theta, and already earlier we've marked it to be 180 minus theta, and thus this theorem stands to be proved. Clear? Right. So these were few theorems that we have, and obviously there is another theorem, that is if you talk about angle in a semicircle, that is 180. Now let's quickly look that up too. So let's say now we have a circle, and let's say the circle look something like this. For that matter, you should remember that sometimes certain questions are asked which are in the garb of a sum, but they're actually asking you the proof of the theorems. So the proof of the theorems should also be known, especially the ones which are important, and that is the ones that I'm discussing, right? So what we want to know is if there is a straight line, that is a chord of a circle which is actually passing through the center of the circle, that is the definition of a diameter. So if we have chord of a circle, right, so endpoints should be on the circumference of the circle, and the center of the circle should be lying somewhere in between. So here we have this to be such a chord which is known as the diameter when it is passing through the center of the circle. Now the theorem is this, that if you talk about an angle which is formed in the semicircle, right, something like this, right, then we have this angle which is formed in the semicircle, right, to be 90. It can also be said to be formed on the diameter of the circle. So the angle which is formed in the semicircle or which is formed on the diameter is 90, and you can make many such angles. Let's have another example. So again, we can draw one chord of a circle, and we can make another chord of a circle so that the endpoint reaches the endpoint of the diameter. Then again we will have this angle to be 90, right? Now how do we prove it? Again, we can prove it very simply. If we talk about the angle at the center, right, we know that the angle at the center is 180 degrees because this is a straight line. We know that this is the diameter. So straight angle, this angle will be 180 degree. Now if you see that this is getting formed where? This is getting formed, now we'll mark the strategic points here. Let's say this be B, this be C, this be D, and let's say this be E, right? At the center of the circle, let's say it be P. So if we talk about the angle which is getting formed at the center of the circle, right, for the segment of the circle to be B, C, D, E, that is a semicircle, then it is 180. So the angle which will get formed on the same segment of the circle, right, at the circumference, it is going to be its half. So it will become equal to how much? It will become equal to 90, right? For that matter, if you try making an angle on the other side even, that is in the other semicircle, then too it will give you an angle of 90 degree, right? So let's try and make one such more. So let's say we draw this to be one of the chords, and then we draw another chord like this. So now if you talk about an angle, right, which is getting formed here, let's say we talk about this point to be point Q, then this angle BQE, right, is an angle which is getting formed in the semicircle, and as such it will be 90 degree. That is because This is an angle which is getting formed at the circumference on the arc of the circle BCDE, and thus it will be half of the angle which is getting formed on the same segment of the circle at the center, right? And since the angle at the center is 180, so the angle at the circumference will be 90, right? So this is another theorem that we have, and we also looked up the proof, remember, right? And whenever you are to do certain sums in geometry, make sure that on the left hand side you write the statements, right? And on the right hand side you write the reasons. So what you've done is on the left hand side, and why you've done is on the right hand side. That is how your theorems are written, and it is expected that when you go for your board exams, you also do it in the similar way. For that matter, when you are to write reasons, make sure that you write the theorems as they are. Like suppose you get to see that there is one angle which has to be proved to be 90 because it is an angle which is in the semicircle. So as such, you will name that angle. It is equal to 90 degree, and the reason will be angle in a semicircle is 90. Right? So when you do it this way, you're not going to lose a single mark. Okay, now children, we will be discussing with these angle properties a sum that I essentially want you people to see. So let's get to that sum. Right, so this say is that sum, right, which I want to discuss now. So initially I'll give you people a little time for trial, say some 10 seconds, right? And you can elongate that period of time by pausing the lecture and trying it for a longer duration of time. For that matter, never miss an opportunity when you get to try out a sum, because that is how you tend to exhibit your intelligence or probably enhance your intelligence, and also so that when the solution is told to you, that is better assimilated and remains with you for a longer duration of time. Okay, now children, we come to this sum. So here we get to see a few things. So whenever you have a sum in geometry and you got to prove something or you've got to find out an angle, make sure that whatever research you can do in this figure, do it and then get to the sum. Then you will get quite a lot of things that you've already done a research on will be required as the answers to the questions. Okay, so one other thing that we get to see here is if you talk about this straight line AB, and if you talk about another straight line that we have as DC, both of these straight lines are intersecting at the point O, and there is an angle AOD which is getting formed, and obviously that's going to be equal to the other angle that is COB, because vertically opposite angles are equal. So this is one of the things that you can do. Then you get to see that there is an angle of 40 degree which is getting formed on DCE. So it is getting formed on DE segment of the circle. So if there is on D segment of the circle any other angle which is getting formed, right, that will also be equal to how much? It will be equal to 40 degrees. For that matter, let's try and draw one chord, and I'll show you that. So if say we join D with A, so we can easily see that if you talk about the angle which is formed, right, on DE segment of the circle by drawing another chord, right? So this angle now DAE will also be how much? It is going to be 40 degree, because angle on the same arc of a circle are equal. So as this angle on DE is 40 degrees, so this angle also is going to be 40 degree. Now for the children, as we have this data and we've done some research, we don't require to do much of research. Let's first quickly try and find out what do we exactly require. In the adjacent figure, O is the center of the circle. Okay, O is the center of the circle. Now there is a special thing which is happening with this O. We have this straight line CD which will become the diameter of the circle, because such a chord which has the diameter of the circle on it becomes the diameter of the circle, right? So this chord is thus the diameter, and thus the angle which is formed on the diameter, or the angle which is formed in this semicircle, is going to be 90. So this is another angle that we now get, right, which can prove to be pretty handy, right? Okay, now that we talk about this triangle, children, DCE, we get to see that if you talk about these two angles, they are known. So obviously we can very easily find out this angle, right? Let's see what next we require. We require to find out CDE. So CDE DE. Obviously, this is that angle that we just talked about. So if you talk about this angle can very easily be found out by subtracting from 180 the sum of 90 and 40, which is 130, and thus this angle is going to become equal to 50 degrees, right? So this angle is 50 degrees. We have this, and this is one of our answers. Remember, we just can't write our answers like this. We have to write it like statements and reasons, which in times to come I will tell you how to do. Next, now we require angle OBE. So OBE is this angle, which is another angle that we require to find out. So now let's look it up. Now, if you talk about one of the triangles here, that is DOB, right? In this, we require this angle. We have this angle. So if we can find out this angle, then obviously we can very easily write this angle. Now we know that this is a straight line. As such, this angle is going to become equal to 105 degrees, right? Angle on a straight line is 180. Or by linear pair, we can say that if one of the angles is 75, the other angle is going to be such that if it is subtracted from 180, you should be able to get to this angle, right? And thus, by linear pair, the sum of both of these angles should be 180. This angle being 75, this is going to become equal to 105. Now, if you talk about the triangle DOB, we have two angles in it. That is this angle of 50 degree and this angle of 105 degree, which sum up to 155, right? And thus, if you talk about the third angle, it should be 25 degree, because 25 plus 155 makes it 180 degrees, right? So we've also been able to find out this second angle, which is OBE, and this is all that you have to do in the sum. So I'll just quickly discuss this, how you could be writing this as statements and reasons. Like I told you, statements are those which are the things that you've done, right? Or the things that you need to do. And then if you talk about the reasons, they are those which tell you why you've done it. So the first point is that we have now here we found out a lot of things, but we'll only be writing about those things which have helped us in finding out first part. Now the first part is CDE. Now if you talk about CDE, this is C, right? This is D, and this is E, right? And remember, this could have been found only because you got to see that this is the diameter of the circle. So the first thing that you're going to say is, you will say that angle DEC is equal to 90 degree. Angle DEC is equal to 90 degree. Right? And the reason here you're going to write is angle in a semicircle. And here you, in bracket, you will say that DC is a diameter. Right? Is 90 degree, right? That is the reason why you've written this angle DEC, that is this angle, to be 90 degree. Now that you have this angle to be 90 degree, right? We've been given that this angle is 40, so automatically this angle, the third angle of the triangle, can be written to be 50 degrees. So here, children, next you will be saying that you have this angle that is O. We are considering now the triangle CDE, right? So you'll talk about now CDE, angle CDE. CDE is the angle as well as it is also the triangle that we are referring to, and that will become equal to 50 degree, and simply you just got to say sum of angles in a triangle, right? Sum of angles in a triangle is 180 degrees. So when you've said this, the teacher automatically understands that you had been given this angle to be 40 degree, right? And the other angle 90 has been found out. As such, the third angle can easily be found out by subtracting from 180 the sum of both of these angles, right? So you need not write much, but this much amount you require to write, right? Which is also the language of the theorem. Okay, Now children, after we've done this, now we come to the second part, and that is you have to find out angle OBE. So here on top, right, you can say that you are actually trying to find out angle CDE, due to which you're writing these statements and reasons. Now for the second part, it is angle OBE. So above here as a heading, you can write that you're talking about angle OBE. Okay, for it now, we'll write the first statement. That is, let's see what we've done first. Okay, so here for the angle OBE, you remember that is this. We talked about this to be a triangle, right? We had this angle to be 50. We just found out this angle by linear pair, and that is the first thing that you're going to now write. That is angle DOB, right? Angle DOB is equal to 105 degree. And here you will write the reason. Sum of angles on a straight line. And for better clarity, in the bracket you can even write linear pair. That means pair of the angles which are getting formed on a straight line, they will sum up to 180 degrees, right? Okay, here for the line, sum of angles is supplementary. Now the word supplementary tells you that the angles will sum up to 180 degree, right? Okay, now next children, after this, using this angle and the angle 50 degree which you found out earlier, by using the sum of the angles of a triangle, we've been able to find out this angle to be 25. So next now we will be saying that angle OBE rather, okay, the same angle OBD is the same as angle OBE, right? Because E is a point on the same straight line BD, right? So you can say that angle OBD, the second point, you can say that angle OBE is equal to how much? 25 degrees. And here you will say that again, sum of angles in a triangle, right? And you can also name the triangle for better clarity. The triangle that we've used is OBD, right? And for that matter, you can even write, for more clarity, this to be equal to angle OBD, right? And further here, as a reason, you can say that the line BD is there's a line BD on which E exists. So you can say that E is a point on BD. So this explains everything. So I'll just quickly discuss this all over. Here children, we have written statements and reasons which tend to explain these two answers that we've been able to find out. The second answer being 25 degrees. The first thing that we did here was that we did a little bit of research as to, we try to find out some angles, but don't do much, otherwise it will be a waste of time. Moreover, your figure will be overpopulated and it can cause confusion. Okay, so the first thing was that we have talked about this angle known to be 40, this angle known to be 75. As such, by linear pair, we get this angle to be 105 degree, right? Now that this angle is 105 degree, we get this angle, okay. Even before that, what we've done is, as these are two straight lines, these two form vertically opposite angles which are equal. As such, this angle becomes equal to 75 degrees, and as this angle is 75 degrees, from that, by linear pair, you get that this angle is 105 degrees. Okay, now further, what we do is, for finding out the angle CDE, right? It was CDE. What we've done is we've talked about this straight line CD, which is the diameter of a circle. As such, the angle in a semicircle or an angle on a diameter will be 90. Thus, we get this angle to be 90. We have this angle to be 50. So in this triangle, the third angle can be got by subtracting from 180 the sum of both of these angles, right? And that comes to 50 degree. And this is what we've written here. So first we've talked about the angle which is on the diameter, right? That is this angle. And we've written the reason, the theorem, which relates it. After that, we talked about the next angle, 50, to be found out by using the theorem sum of angles in a triangle. For the next part, children, what we've done is we require to find out angle OBE, and angle OBE is this angle, which will also be the same if we talk about OBD. That is because BD is a straight line and E is just a point on it, right? And thus, excuse me, one of the first things that you do is, as we already know that this angle is 50, this angle can be easily found out by linear pair, as some of the angles on a straight line is 180. So this is what you write as the first statement. You say that if you talk about angle DOB, that will be 105, because sum of angles on a straight line is supplementary, that is by linear pair, right? And here further, you now have two angles of a triangle, so obviously the third angle can be found out by subtracting from 180 the sum of both of these, right? So that is what you've written, right? Sum of angles in a triangle, just name the triangle also. And E is a point on BD, right? Which you write to show that if you talked about OBE, it's going to be the same as OBD, because BD is actually the same straight line, right? So if you talk about angle OBE or if you talk about angle OBD, it is one and the same, and that too has been registered here. So this way, children, if you do the sums, I'm sure you will get full marks in your board exams in questions on geometry. That is where normally children falter. So I'm sure all of this you people must have understood, right? If so, do give me a thumbs up, right? I'm going to make a post now and I'll provide this to you for your understanding, right? And what else you require and how I can help you, do let me know. And I'm always standing here to help you people out so that you can better your mathematics and in times to come have a better logic and heal the world. That is the one that you're going to rule tomorrow. Bye, children. Have a nice time. Bye.